All right, we are going to now work on a rational inequality. Rational meaning ratio, which means it kind of looks like a fraction. X plus 4 times x minus 1 all over x plus 3. And we want to know when that's greater than or equal to 0. Okay, now if you want to, you can take a look at how the graph of this looks on your calculator, but you don't really absolutely need to. Here's the thing. This graph will only cross the x-axis. There's only 3 possible places that can happen. The first comes from where is the top, because it's greater than or equal to 0. So where's the top equal to 0? Okay. Well, does it make sense that this part right here would be 0 at -4? So we have a critical value of -4, meaning that's a potential spot, and it actually is equal to 0 there, so you could put that as a point, okay? Critical value is basically going to tell you where the function equals 0 or where it's undefined. So the other place, or one of the other places that you would have the function equal 0 is at 1. So we're also going to plot a critical value at +1, and again, that's where it equals 0, so go ahead and fill that in, okay? And then the third critical value doesn't come from where the function equals 0, but where it's undefined, which would be at x equals -3. Oops. Sorry, -3. Now, you obviously do not want a 0 in the denominator, so that is a critical value, but we wouldn't include it because that would give us a 0 denominator. Okay, so these 3 points are the only places where potentially the graph could cross when it's graphed from above the axis to below the x-axis or vice versa. So the way that you tell where it is greater than or equal to 0 is I just pick some test points. So let's pick a test point, maybe let's say 0. Now, here's what I do. There's a couple ways to do this, but x plus 4, x minus 1, here's the function, over x plus 3. You don't really care exactly what that equals. You just want to know the sign of it. So if I'm going to plug in the 0, okay, if I put a 0 in here, I'm going to get a +4, right? So just worry about the fact that that factor is positive. If you plug a 0 into the second factor, x minus 1, you're going to get a -1. So this is, the top is a positive times a negative, right, which would be a negative on the top. On the bottom, if I plug a 0 in down here, I get a +3. So a negative divided by a positive, okay, would be negative. So this, from between this critical point right here and this critical point right here, the point that I chose is negative, meaning all of them in between there would be negative, okay? Now you might want to pick a point, let's go to the right, and let's say maybe pick another test point, like maybe 2, okay? Now let's erase these, and we're going to do the same thing as if we put a 2 in. So if we do that, we get a +6, we get a +1 and a positive. So positive times positive over positive is positive over positive, which is positive. All right, we're moving along. Now, I won't probably take the time to do all 4, but maybe you might try something like 3.5, and you might check something like a -5, okay? But if you do that, I'll tell you what you get so you don't have to watch me do it. This one comes out to be positive, and that one comes out to be negative. Now, a lot of times they alternate, but they don't always necessarily alternate, so you do want to check the points. If you don't like this way of doing it, the other alternative is just put this thing under y equals, you know, the very top left button in your calculator, and then do a table and plug in all your test points, and then it's a little quicker too if you don't mind typing it in your calculator. But no matter which way you do it, the question is asking me where is the function greater than or equal to 0, which means where is it positive. So this area in here and this area here are where it's positive, which basically means, the graph of this function will be greater than 0, meaning it'll be above the x-axis. So if I want to write that in interval notation, okay, this piece of it is, we're including the -4. So bracket -4 to -3, but that's got a circle around it, that -3, so use a parenthesis. And then again, we have another area right here, which is bracket 1 to positive infinity. And that's your final answer. That tells you where this original function right here, where it is above the x-axis.